Hello everyone. There is another interesting problem about the supersonic plane. The problem states a supersonic plane is flying horizontally. Two microphones located on the same vertical at a distance L from each other recorded the arrival of sound from an airplane flying over the microphones with a time delay delta t. Speed of sound in air is given as c, and the question asks what is the speed of the plane. So this is another very interesting problem. So my problems always start with a very nice and accurate drawing. So first of all, we have to understand what supersonic plane means. Supersonic is a plane that can fly at a speed higher than the speed of the sound. Okay, so to understand this, so let's say that this is my plane. And it travels at the speed v, which by the way we don't know and we are trying to find it. As you might know, every plane makes noise, right? Because it's going through the air, so it could be engine sound or any other sound. So at any point, if this plane makes one signal, let's say a signal of a beep, okay, like one short beep signal. After some time, the signal travels distance x, which actually becomes like a circle. So this is the front of the wave. So the sound reaches everywhere along this this line. But since the speed of the plane is faster than that, so plane should be somewhere here. So it's traveling faster than the speed of the sound itself. So it's very important to understand this. So if we have, so let's say if we have a special sound making device on a plane that makes this beep signal every other specific time frame, let's say every second or every 10 seconds, it makes this beep signal, and we want to focus only on this beep signal, right? So let's say that our plane is traveling at a constant speed, and then after every specific time, like 5 or 10 seconds, it makes this beep sound, okay? So let's say that the first beep signal happens here, okay? So it actually propagates from this source, and then there is another beep signal that comes from this second source. And then there is another beep signal that comes from this third source, and then there is another beep signal that comes from the last source. So obviously our plane by the time it makes another beep sound, our plane will be here. Okay, so by the way, this is the time. Let's say this is T1, this is T1. So by the time this first source reaches the point that makes this large circle from source 1, our plane will already be here. Our plane will already be here. So you see that the speed of the plane is faster than the speed of the sound, but it makes this beeping sound every 5 seconds. So let's say we have a specific device that makes a beeping sound every 5 seconds. So it makes this kind of a cone shape, right? Where this distance, c times delta t, while this distance here that plane makes during that same time is v times delta t. Okay, so it's very important to understand how sound propagates in air and how the speed of the plane also visualized like this. So as the problem states, we have two microphones located vertically. So let me draw another picture. So there is a plane going along the straight line, and there are two microphones, A and the B. So the distance between them is L. And then they detect the first sound of the plane. Of course, in this case, we don't have the beeping sound. The sound of the plane is continuous, right? The first time microphone A detects, it detects first, and then microphone B detects. And the time difference between their detection is delta t. It's the time difference. And the c is given as the speed of sound. And then we have L, distance between microphones. Okay, so what happens is, if you visualize it, that when the plane reaches this point, the sound, the cone of the sound would be like this. Okay, so when plane reaches this point, the cone of the sound would be like this. It will be making exactly the same angle. So the sound actually propagates this way. This is the front of the sound that are propagating at the same speed. And then eventually when, let's say, when plane passes above A and the B, the front of the speed of sound is here. So you see that the sound has reached microphone A first. It has not reached the microphone B yet. So the plane needs to reach another point at a later time in order for the sound to reach B. So from this picture, we can already make a very interesting picture. So we know that microphones A and the B detect at the distance of time difference delta t. So this distance becomes c delta t. Okay, distance becomes c delta t. And then it's very important to understand from geometrical point of view that this angle alpha here is same as this angle alpha here. Okay, same as this alpha here. And if we go back to our previous picture, so this is our angle alpha. So from this picture, we can see from this picture here, we can make the following relation. We know that sine alpha equals c delta t over v delta t. Okay, sine alpha, the delta t's can be cancelled, so eventually we will get c over v. So this is a very important result that we will use shortly. And from this picture here, from this triangle here, we get a cosine alpha equals c delta t over L. So delta t will be useful here. The delta t is a time when microphones A and the microphone B detect the speed of sound, the difference of time. So this is another important result that we have. So once we understand this, the rest is very easy. So we know that sine square alpha plus cosine square alpha is a 1. And the sine alpha is a c over v. So it's a c over v plus cosine alpha is a c delta t over L. And we have to square them and equate to 1. So the rest is just a simple algebraic manipulation in order to get the speed of the plane v. I'll keep c delta t together. So 1. c squared over v squared equals 1 minus c delta t squared over L squared, or L squared minus c delta t squared over L squared. So v squared equals c squared L squared over L squared minus c delta t squared. And if we want to know the v itself, it's cl over square root of L squared minus c delta t squared. Okay, this is our final result. I know it's a bit challenging, especially the drawing part. I drew so many pictures just to give an idea how sound propagates in air and how plane is located along with the propagation of the sound. So once you understand this, you see that this equation and this equation are very simple, but it's very challenging to get those two relations. And after that, it's very simple mathematical manipulation to get the final result. Okay, please subscribe to my channel. If you have any questions, or if you find any of this explanation confusing, please let me know. I hope you enjoyed. Thank you.